All right, here we go. This is assignment 5E. This is a worksheet. This is all pretty much trying to understand, do you understand derivatives and second derivatives? Do you kind of see what they apply or see what they don't apply? That sort of idea. Um, real quick before we get going, what you really need to know is the first derivative. Okay, if it's positive, okay, that means the line is increasing. If the derivative is negative, that implies that the line is decreasing. If the second derivative is positive, that implies that it's concave up. Okay? If the second derivative is negative, that implies that it's concave down. Okay, other things that you probably want to know is if there is a derivative equal to 0 on a concave up, it's most likely a minimum, most likely. If there is a derivative that is equal to 0 on a concave down, it is most likely a maximum. If you see a second derivative equal to 0, most of the times that isn't implied that that is the switch between a concave down to a concave up. A lot of times, again, not all the time, but a lot of times. And so that is a lot of times implying that that is a point of inflection. All right, so these are some things that you kind of want to keep in mind as you go through these things. All right, so we are given some criterion. The only criterion that we really have to follow is just make sure that this thing is continuous. We don't have to make sure it's differentiable. All we have to do is make sure it's continuous. And so that makes our life really easy. Okay, understanding what we have over here, let's take a look at the stuff that is below C. So I see that the derivative is positive. That means this is increasing. And that the second derivative is negative. That means it's concave down. All right. On the right-hand side, it is negative. That means it's decreasing. And it is concave down as well. All right. So increasing concave down, decreasing concave down. That one's pretty easy. All right, left-hand side, I see that the derivative is positive, so that means it's increasing. And the second derivative is also positive, that's concave up. Over on the other one, we see the first derivative is negative, so that means it's decreasing. And the second derivative is negative, so that means it's concave down. So we have an increase concave up, a decrease concave down. Again, it doesn't have to be differentiable. Question 3, left-hand side. First derivative is positive. That means it's increasing. Second derivative is positive. That means it's concave up. Right-hand side, the bigger than the C. The first derivative is negative. That means it's decreasing. And the second derivative is positive. That means it's concave up. So increasing concave up, decreasing concave up. Check. Again, they don't have to be differentiable. All they have to be is continuous. All right, number 4. Left-hand side of the C, we have the derivative that is less than 0. That means it's negative. That means it's decreasing. Second derivative is positive. That means it's concave up. The right-hand side is positive, so that means it's increasing. Second derivative is negative. That means concave down. So we have decreasing concave up, increasing concave down. Okay, Here they get a little bit more tricky, I guess. I don't know. So the left-hand side, I see that the second derivative is positive, so it's concave up over here. Right-hand side is concave down. I see that the derivative itself is 0, so that means that there is going to be a horizontal tangent line somewhere. And I see that the second derivative is 0, so that is implying that there is a point of inflection there. So there's going to be a point of inflection with a horizontal tangent. So concave up to a concave down would probably look something like that. All right, so nothing for the less than c, everything for the bigger than c. So I see that the first derivative is positive and the second derivative is also positive. And I see that the derivative at 0, or excuse me, at c is 0. That means there's a horizontal tangent line. So it can really do anything that you really want it to do. I'll just say it does that. All right, the rules that I have to follow on this next one. See, the left-hand part of the C is second derivative bigger than 0, so that means it's concave up. And then the right-hand side is also concave up. Oh, this is the one that I'm really kind of confused about. Okay, so here we're going to have a horizontal tangent. And we also have it looks like a point of inflection, but there isn't an inflection point. So it's a concave up to a concave up. And it appears to be differentiable because we actually have a derivative at 0. So here's, again, I'm not really sure. I think this might kind of like really fizzle out to like a U kind of looking thing. I'm not really sure. That one's a question mark. Maybe somebody brighter than I will figure that one out. All right. Here we have the left-hand part to be decreasing, because it's less than 0, decreasing. This is concave up. And then we have the derivative equal to 0 somewhere on here. This side is decreasing, this is concave up. Okay, here we have a derivative. Okay, so let's start with the derivative that we can see. So we see that there's a derivative at c that is equal to -1. So that means there's a slope of a tangent line equal to -1. It's going to mimic that somehow. All right. Also, I see that the second derivative is 0, so there's most likely an inflection there as well, most likely. And so here we have a concave down, and this is a concave up, following those two rules. So concave down to a concave up. All right, again, start with the derivative that you know. So the derivative, the slope at c is 1/2. So there is a point somewhere, and this slope is 1/2. All right, the second derivative is 0, so it's most likely, again, an inflection. Left-hand side is a concave up, and then we have a concave down. So a concave up to a concave down. It'll be exactly the same as before, but just try to follow that tangent line that is predetermined. All right, so here we have a derivative that does not exist. So what that means is that's probably a point or it can't be a discontinuity or something like that. It's probably a point of some sort of chevron, something like that. Okay, so the left-hand side is concave up. Right-hand side is also concave up. And so we want some sort of point existing. So concave up, concave up. All right, this one is kind of like a well, duh. Again, we probably want a point of some sort. And because this is not differentiable, that implies that that second part is also not differentiable. So yeah, that's a oh duh statement. All right, so here we have a concave down and a concave up. Again, so concave down and a concave up. Something like that. All right, these look a little bit more scary than what they really are. What I try to do is I start with the concavity. That's usually the easiest part to kind of distinguish. All right, so I see that D is the separating point. To the left of D, it's concave up. And to the right, it's concave down. All right, see if they give us any derivatives that they want us to follow. And so D, at line D, there is a slope of 1, a tangent line of 1. So I'll just kind of approximately draw that in. And what do you know? They also give me a second derivative of 0, so that is also most likely an inflection. All right, now notice on the flanks at the C and the E, both the derivatives are equal to 0. So that is most likely a maximum or a minimum. Most likely a maximum or a minimum. And so at the C, it's equal to 0. So during a concave up, when you get a critical point, that's most likely a minimum. Most likely. Okay, so it's like a critical point. It's the second derivative test. Similarly, on the E line, we got a derivative of 0. So again, a critical point on a concave down is most likely a max. Most likely. Again, not all the time, but most likely. So this is most likely a min, and this is most likely a max. And so it kind of draws itself right here. So I'll just follow the picture. So I have a concave up, concave down, something like that. All right, so the concavity is again split at D. So we have a concave down, concave up. D has a tangent of -1, and also has a second derivative equal to 0, so that's most likely an inflection. C has a 0, so during a concave down, this is most likely a max. E also has a 0 as a derivative, and so during a concave up, that is most likely a min. So it should probably be the exact same thing as the previous picture, just inverted. All right, so now we're getting a little bit more complicated. big deal. All right, again, take a look at inflection. So D is at least one of the cutoffs, and to the left of it, it will be concave. It's negative, concave down. Then from D to E, it's concave up. And then it is concave down again beyond E. All right, so take a look at so we took care of the concavities. Take a look at the derivative that you do know, and that D is -1. So D is -1. All right, the second derivative is equal to 0, so that is most likely an inflection. First derivative at E is 0, so this is most likely, well, I don't know, well, because it's not purely, so it looks to appear to be a min, but it's not really a min because it's not purely concave up, concave down. So I think this is going to be like a hiccup, because I also noticed that this is also an endpoint of inflection with the second derivative. Okay, the only thing left on our, so again, this is not what I'm explaining, is this is not really a min. This is what I kind of call a hiccup. It'll start to look like it's going to be a minimum, but notice how the inflection changes. I'll show you what that looks like. Last but not least is the C, and the derivative is 0. So again, that is straight up most likely a maximum. All right, let's do work. So again, try to follow, I start with the middle, and I'll just knock off this maximum, and it comes down like this. So this is concave down. Now I switch to concave up, so it looks like this is going to bounce and come up, but then it switches. And so that's what I kind of consider to be a hiccup. Let me draw that one more time to see if I can make it just a little bit more clear. I don't like my drawing in the middle there. Let's try this one more time. All right, so we have concave down, concave up, concave down. Yeah, that's a pretty good picture. All right, let's start with the concavity. So less than D is concave up. Between D and E, it's concave down. And then it switches back to concave up again. So the derivative that I do know is D is +1. Now again, no, this doesn't have to be at the the x-axis. This could be anywhere on D. It doesn't really matter. It's just like, you know. It's also a point of inflection because the second derivative is equal to 0, and it's the concavity is switching. So at E is a tangent and an inflection, so this is another one of those hiccups. So this is most likely a max, but not really, because this is a point of inflection. And so this is not a max, but rather a hiccup. And that's just my own made-up word. It's not a mathematical word. And then at C, we have a horizontal tangent, and that, again, is most likely a minimum. So drawing this picture, right here, we're going to switch to a concave down and a concave. Okay, pretty much all of these problems are the same. They just kind of rotate them around. All right, so less than C is a concave up. Between C and D is down. above D is concave up. Okay, at D is -1. At E is, oh, and it's an inflection. At E is, the tangent is 0. So that's most likely a min. And then at C, we have a tangent of 0. That's most likely a max. But because it's an inflection, it's most likely a hiccup. I'm going to do this one in silence. I think you guys know what I'm doing by now. That's it.